This is a lesson on solving logarithmic equations. So learning goal, students will be able to solve logarithmic equations today. So it pretty much encompasses everything we have been learning up until this past week. So here are formulas that we are going to need to know in order to solve for our logarithmic equations. So here's a product rule. So if we have log base b of m times n, that's going to be log base b of m plus, let's see, log base b of, hold on one sec, log base b of, there we go. So it's going to be log base b of m plus log base b of n. So that's the product rule. For quotient rule, it's going to be log base b. If it's m divided by n, it's m minus log base b of n. And power rule, bring the exponent to the front, so it's going to be n log base b of m. So that's the product, quotient, and power rule. We also need to know how to convert from logarithm to exponential form and vice versa. And this is the new equation where it's going to be, if you guys have a log that's equals to another log and they have the same base, then this is going to equal to this quantity. M is going to equals to n. So basically, to solve for logarithmic equations, you have to get a log equaling another log, because then you guys can set both of these arguments equals to each other. Or you guys need to get a log equals to a number. And if you do get a log equals to some number, then you can convert from log form to exponential form. And you guys solve for x, and you check for extraneous solutions by plugging in back into the original equation and making sure the inside of the logarithm is not 0 or negative. If you guys plug in x value that you found into the original equation, and that simplification is negative, like you get log of a negative number, then that is an extraneous solution. And if it's log of a 0, then that's also an extraneous solution. So we should just try a couple of these to see, right? So notice we have log and equals a log, right? So then we just equate both of those together. And then we solve for x by putting variables to one side. So I'm going to choose to put it on the left, and putting constants to the right. Divide both by 4, x is equals to 9. And if we plug in 9 into here, you guys, 25 minus 9 will give us positive 16, so that's fine. If we plug in 9 into here, 3 times 9 is 27, 27 minus 11, 16. So that gives us a positive there. So this will be perfectly fine. That will be perfectly fine. Now for example 2, again, log equals another log, right? So you guys set both of these equals to each other, and we get 4x minus 7 equals negative 3x. So we solve for x from here, so I'm going to get my variables to the right hand side this time, and then divide both sides by negative 7. So x equals 1. But everyone take a look. If I plugged my 1 into here, because you guys got to plug it into the original equation to check extraneous solutions, you're going to get log base 7 of 4 times 1 minus 7. And on the other side, you're going to get negative 3 times 1. On this side, you guys are going to get negative 3. And on the other side, too, you're going to get negative 3. A log of a negative number you cannot have. It's undefined. So this we gotta cross off. And because we don't have any other answer, our answer is no solution. You have to plug in your final answer, you guys, into your original to see if you get logs of negative or positive. Example 3. So we have a log equals a log, so we got x squared minus 21 is equals to 4x. So since we're dealing with quadratics, we gotta set the equation equal to 0. So I'm gonna subtract 4x from both sides, x squared minus 4x minus 21 equals 0, and then you guys, we factor. X minus 7 times x plus 3 equals 0, so x equals 7, x equals negative 3. So if we plug in 7 in for our x's, you guys, it will be fine because both of them will turn out to be positive. But if you guys plug in negative 3 into either of these, 4 times negative 3 would be negative 12, and log of a negative number, you guys, is bad. It just takes 1 to produce an extraneous solution. So that's gone, so that means our only answer is x equals 7. So here are 2 doyos. You guys should definitely try it out first, pause the video, and once you guys are ready, then play the video back. So hopefully you guys, you tried it. So we have a log equals a log, so 5x plus 10 equals 2x minus 8. Get variables on one side, so I'm going to put it on the left hand side, and get constants on the right. Divide both by 3, x is equals to negative 6. And if we plug this in into the original equation, we're going to get negative answers for both of these. A log of a negative number is never good, so that cannot be an answer. So we got no solution because we have no other answers we can choose from. So scale that from 1 through 5. Now we have number 2. So we got a log equals a log, so set the arguments equals to each other. So since we're dealing with quadratics, we gotta set the equation equals to 0. So we factor using x method, x minus 5 times x plus 1, so x equals 5 and x equals negative 1. And if we plug in either of these into here, you guys, we get positive log values. So both of these will be our answer. And again, scale it from 1 through 5. So that was log equals a log. Now we're about to do log is equals to a number. And if it's log is equals to a number, you guys have to convert it from a log form to become exponential. So you guys will see. So I'll write the log form down here so that we always have a frame of reference. And I'll write exponential form over here so that we also have a frame of reference over here. So so we have definitely on the left hand side it's going to be a log, and on the right it's going to be a number. So this means we have to change it from log form to exponential form eventually. So let's first condense this using your guys' product quotient or power rule. So if we condense this, you guys, log base 2 goes into 1 log, right? That's what it means to condense. Since it's a plus, x times 2. That's your guys' product rule. So 2x equals 6. And now, since we have log form, we're going to convert it to exponential. Take the base, raise it to 6, and make it equals to 2x. 64 equals 2x, divide both by 2, x is equals to 32. So that's how we solve for these type. Guys gotta get log by itself and then make it equal to a number, and then change it to exponential form and then solve from there. Okay, so this definitely looks like 1 log gonna be equals to a number, so we're gonna have to convert it from log to exponential. So condense this, so log base 3, so since it's plus, we multiply this times this. X times x minus 2 equals 1, so we're going to do some simplification there. X squared minus 2x equals 1, and now, since it's in log form, we got to convert it to exponential. 3 to the first power equals x squared minus 2x, and then subtract 3 to both sides. 0 equals x squared minus 2x minus 3. And if you guys factor that using your guys' x method, x minus 3 times x plus 1. X equals 3 and x equals negative 1. But we have to plug it in. And if you guys look, if we plug in negative 1 in for the x, that's log of a negative number. So that's not going to work. And if we plug in 3 into here, you guys, both of these turn out to be positive. So x equals 3 is our answer. Example 6, and I'm going to drag down this log form and exponential form so we have a frame of reference. So this one certainly looks like it's going to be a log versus some type of number. So we got to condense this, but we need to move this 2 to become the exponent of the 3 from power rule. Rewrite everything. We got a log plus a log, so when we condense this, this is your guys' product rule. So it's 3 squared times x, 3 to the second is 9, so it's 9 times x for 9x equals 4, and then change it to exponential form. Base of 2 raised to the 4th power equals 9x. 16 equals 9x, divide both by 9. X is equal to 16 over 9. And that is the answer, because when you guys plug in x equals 16 over 9 into there, that's going to give you guys a positive value. And lastly, example 7. So this is another, it looks like it's going to be a log versus some type of number, so we are going to have to convert it to exponential form. So condense this, so log, since it's a minus, it's quotient rule. X divided by 4. And what's the base of a log? That doesn't say. The base is always 10. So we're going to rate 10 to the 2nd power equals x over 4. So it's 100 equals x over 4. And because this is divided by 4, the opposite of that is multiplying both sides by 4. 4's cancel. X is equals to 400. And if you guys plug in 400 into here, it's going to give you guys a positive log value. Alright, so make sure you guys do your exit ticket summary and make sure you guys fill this stuff out. Alright, so hopefully this helps you guys out for your guys' homework on this. Alright, good luck everyone. Peace.